Welcome everyone to our December education session on waste heat recovery. This is a topic that the Seattle 2030 district has been working on with King County for a couple of years now. And now that the pilot is up and running, we wanted to introduce everyone to it with Erika and Carl. And then we've brought in Ryan from Sharc to talk about their solution. And then also Brad from McKinstry, who's worked on a number of district energy projects here in the Pacific Northwest. I'll actually let the presenters introduce themselves before their presentations, just so we can save a bit of time. But first, I wanted to give a quick introduction on the format for this morning. So we'll have presentations from King County, Sharc, and McKinstry. And if you have any questions throughout, please use the chat function. And then I will try to get to all the questions at the end. If we have time, like I said, we'll open it up for a discussion. Hopefully we'll have about 10 to 15 minutes for those questions. And like I said, the best way to get through all of those is to probably use the chat function, and I'll get to them. But I'd like to start just by giving a brief introduction to the Seattle 2030 district and what we do. So we are a business model for urban sustainability through collaboration, leverage financing, and shared resources. We are a public-private partnership. And the reason I say public-private first is we're private sector led because we've seen public sector programs lag sometimes in the past or even fail when there's a change in administration. I'm sure that is the same for others across the world and not just Seattle specific. So what the Seattle 2030 district allows is for private industry to set the initiatives and what that looks like over the next several years. And then have the public sector support those initiatives with their policies. So we have a shared mission and a goal, which is very important when trying to make a change like this on a large scale. So if you don't set a goal, then A, you're never going to achieve it, and then you can't manage what you don't measure. And the time frame is also pretty important. The year 2030 is actually not very far away now. But we still think these goals are achievable. We'll also be around for that period of time, at least I hope so. And we may even own an asset for that period of time. And we know that globally, we need to achieve these carbon neutral buildings and high performing buildings by that time period, according to climate scientists. So what is the goal? So the goal of the 2030 district is to achieve a 50% reduction in energy, water, and transportation emissions by the year 2030 with interim goals in that time period. And then for new construction buildings and major renovations, the goal is to get to carbon neutral by the year 2030. The current goal is an 80% reduction in energy use from baseline, and just as a comparison, that's about 25% better than current Seattle energy code. And as I mentioned, the shared mission of the district, this is kind of the reason why so many building owners like the district model. So the goal is a district goal and not an individual building goal. So you commit to achieving the goal, and you might be able to go above that 50% for your building if you are a newer building. But if you're an older building, you might only be able to achieve maybe a 30% reduction. But on average, we're going to be able to achieve that 50% goal in the district and put us on that path to climate stabilization. So as you can see here, just kind of where the district is, we work in the downtown area of Seattle and the surrounding neighborhoods. We currently have 260 member buildings committed to the goals, and that is around about 60 million square feet. So what do we do for those members? Well, first of all, we convene our business leaders and government officials, kind of like what we're doing here on this presentation. to create policies and incentives that work for both parties to achieve the district goals. We provide education sessions exactly like this one for our property owners, managers, developers, and our professional stakeholders on new strategies to achieve the goals. And most recently, we've been concentrating on how to reopen buildings with occupant health in mind, while also improving efficiencies. And if you're interested in seeing any of our past presentations, the beauty of doing all of this online is you can see them all on YouTube now. We also provide demonstration projects with new technologies with our members to bring the products to market quicker. We advocate for new policies and incentives. We facilitate conversations amongst building owners to share their information. It's actually one thing that members agreed upon when the district first was founded, was that building owners compete on pretty much everything to do with their buildings, but they didn't need to compete on climate change. And we try and provide a space for them to share that knowledge. And lastly, we celebrate our members' achievements. We provide case studies, or at our annual Vision Awards, we give out 4 awards to members who have showcased exemplary buildings in energy, water, transportation, and overall leadership. We just had our Vision Awards on October 15th. And again, if you're interested in seeing that show, it is on YouTube. We had a great keynote speaker with Jamie Margolin this year. So the IPCC report really shows that we need to get to net zero emissions by the year 2050. And to do that, it is essential that we reduce emissions by 50% in the next 9 years and 28 days. The longer that we take to reduce those emissions, the more severe our annual reductions are going to become to get to that 2050 goal. And that goal gives us a 50% chance of achieving a 1.5 degree temperature rise. And I'm sure, as most people on this call know, buildings generate about 40% of those emissions. So the work that we all do here has a direct impact on whether we're going to achieve that goal and win this fight against the climate crisis. And this year here in Seattle, we've seen the contrasts of what we could have if we make significant changes. The slide here on the left is the clean air that we had at the start of the pandemic when transportation was massively reduced. And then you can compare that to the slide here on the right to what our future could look like if we really continue on this path. These are the smoke-filled skies that we had here in Washington, with the climate fires that we had in Western Washington that we saw in the summer. And I think now we're just at this time where there are so many opportunities available to us to scale down this wasteful consumption through smarter building methods in new construction, retrofit improvements in existing buildings, and there are a plethora of incentives available to us now to help pay for a lot of those upgrades. And here today, we're going to talk about one of those opportunities with King County and waste heat recovery. But before I hand it over to Erika in King County, I would like to thank all of our annual sponsors. Without them, we would not be able to do the work that we do and put on sessions like we have today. And this year, honestly, their support has meant more than ever, just kind of given everything that is going on in the world. And then the same goes for our 2030 district funders, the Boeing, the Bullitt Foundation, and King County. So thank you all for being here today. It is a pleasure to see you all, and particularly those from across the world. And with that, I will hand it over to Erika.
Thank you very much. It is really a pleasure to be here today. I am working on getting my screen shared for you.
Perfect.
Yeah, you can see that? Okay,
yep.
Great. Yeah, so we're here to talk about sewer heat recovery. We're really excited about this as an innovative renewable energy source for our community. And speaking today is me. I work for King County's Wastewater Treatment Division. I do research and policy, project management, and this has been a special project for me over the past couple of years to really spearhead the program development, the policy, and the contractual elements of sewer heat recovery for our utility. And then I'm going to be sharing this presentation with Carl, who is our energy program manager. Carl, do you want to introduce yourself right now? No. Okay, he's gonna come on later and he's gonna tell us about himself. So what we're gonna do is I'm gonna tell you a little bit about sewer heat recovery in general and how WTD, that's our wastewater treatment division, how we're launching this new program. Carl's gonna talk about the concept and how that technology works in high level terms. And then I will finish up by letting you know next steps, how WTD is going to review potential projects and work with users. And then of course, we want to answer your questions. And as Matthew said, we're going to hold those till the end after all of the panelists have spoken. So just to jump right in, how does sewer heat recovery help the environment? First, reclaiming wasted thermal energy is more efficient than any form of new energy generation. And the thermal energy that is contained in the world's sewers, that's an enormous untapped resource. I have read estimates that 90%, that's 90% of the energy that we use to heat our water is flushed down the drain with the water. So of course that's a waste, right? And sewers worldwide have an average temperature of about 65 degrees. To put the scale in context, the US Department of Energy estimates that 350 billion kilowatt hours are discarded annually down drains in the form of heated water. And as a frame of reference, the annual US commercial building energy consumption totals approximately 1,200 billion kilowatt hours annually. So in theory, sewers contain enough energy to supply about 1/3 of our commercial buildings. And then the next question is, how is sewer heat recovery good for business? As Matthew has just detailed, there's lots of good reasons to try to lower your property's carbon emissions. And if you're a Seattle 2030 district member, you have made commitments to do that. So this is one way this is one strategy to do that. It might help you meet more stringent energy codes. And it's also a way to leverage your green building efforts to let your tenants, your buyers, your investors know about this, and it could be a selling point. So this is a simple diagram of one example of how sewer heat recovery works. And we're going to show you this slide later, so you'll see this again. But in general, buildings discharge heat down their drains in the form of hot water from showers, dishwashing, commercial enterprise. And then this is just an example system showing how a building can tap into that and aggregate that heat from the sewer to heat or cool their building. So what's the potential here in King County? We've got, this is a map of our large interceptor pipes. The red lines are raw sewage influent that are coming into our treatment plants, and the green lines are effluent, that's the treated effluent going out to the sound from our treatment plants. And so these are large pipes in dense areas, populated areas, and they have greater flows and more consistency than some of the smaller feeder pipes that feed into this system that are owned by our partner sewer agencies. So King County's interceptors may be best suited for that reason for sewer heat recovery. And key factors, of course, for thinking about whether sewer heat recovery is a good fit is how close the property the user is to the pipe and then the flow in that location. So stepping back to give you a little bit of an overview of how we got here. The wastewater treatment division has been approached multiple times over the last decade or so by private developers who were interested in sewer heat recovery on their projects. And for various reasons, it hasn't come together yet. It hasn't worked out yet. And one key barrier that we had identified is that a property owner's timeline and our government legislative timeline don't align, meaning that when a developer has decided that they are interested in sewer heat recovery, they're ready to design their system, they're ready to move forward and think about construction. And these kind of agreements from the utility side have to be approved by our King County Council, and that legislative process usually takes just a lot longer than a property owner has to wait. So we took a step back a couple years ago and approached this with some goals and commitments. The goals on the left-hand side here were, number one, to help our community lower carbon emissions. We felt we had a resource to help our community do that, and we wanted to find a way to share that. We wanted to have a template contract to address the issue that I just outlined. That would it would be something that we could sign quickly and that we could provide to users, potential users up front, so they could see what our terms were and whether that would work for them. And then finally, we wanted to make sure that there was a reasonable compensation back to our ratepayers who are flushing, who are paying to heat that water and are flushing all of that heat energy down the drains. So our commitments on the right-hand side have been, number one, that wastewater conveyance and treatment is our primary mission. So anything that would jeopardize that would be a non-starter for our utility. For that reason, in part, any user would bear all the cost and the risk to construct and operate the system. And then also that we wanted to do, in order to address that reasonable compensation to ratepayers, we wanted to do a limited number of pilot projects to assess an appropriate rate for that energy that is transferred. So this is just a process map showing that 2 years ago, we decided to draft up a contract. We put it out for stakeholder review in partnership. We helped, the Seattle 2030 district helped us go out to the community, the developer community, to see, what parts of that contract were attractive, what weren't so attractive, so that we could learn about that. We revised it in spring of 2020, sent it to the council in June of this year, and it was approved in September by our council they authorized a template contract that we could sign with users and authorized us to do that with up to 3 pilot projects. So I'm going to turn it over to Carl for the next few slides.
Thanks, Erika. So I'm Carl Grodnik, and I also work in King County Wastewater Treatment Division's Resource Recovery section with Erika. I lead the division's energy program, where we focus on all things related to efficiency and renewables throughout our process at all our facilities. So sewer heat recovery, it's been used to heat buildings for years all over the world. It's not old. It's used nearby in Vancouver, BC, Europe, Japan, and a few spots in the US. In the US, until recently, it's been used primarily by wastewater utilities to heat their own facilities, including by our own South Treatment Plant in Renton, which we've been doing since 1988, actually. However, instead of using heat from raw sewage, South Plant actually takes the heat from the treated plant effluent to provide heat for the digesters and buildings at the facility. Their heat pumps are currently out of service and in the process of being replaced with a newer, more efficient design. The most famous example of sewer heat recovery you may know of, especially in this area, is the Falls Creek system in Vancouver, which was built as part of the Olympic Village. Vancouver's utility decided to build and manage the district's energy system as part of the redevelopment of the neighborhood after the Olympics. And so, as I mentioned, now the uses in the US are also broadening outside the wastewater field and just getting more into general building heat. The American Geophysical Union headquarters building in DC was built as the first pilot project there. And between a utility, DC Water, and the privately owned building. And then within the last few months, the Denver Metro Wastewater Reclamation District reached a deal to use sewer heat recovery at the National Western Center, which they believe to be the largest sewer heat recovery system in the country now. I think we can go on to the next slide. Yeah. So how does it work? Again, Erika, you saw this graphic earlier, but it's good, so you get to see it again. It's pretty simple in that it's got where all the stuff comes from, the water, sewage, and the heat. and in the main sewer pipe there, and then the general path the sewage takes to make it all happen. The user's holding tank, it's not directly in line with our sewer mains. It is for this graphic. It just kind of helps simplify it. But there are two taps into our own pipe. One to take flow or a portion of the flow out of the main and into their pipe, and then one to return the sewage with it back into our own main. Once it's in their holding tank, that's where systems can differ depending on their own design. But generally, they're going to have a pump to get it out of the tank and through a heat exchanger. And there are obviously different types of HVAC systems to generate additional heat and distribute it around the building after that. But that's pretty much it. Why don't we try the next slide again? So these are, we say system requirements here, they're not actually requirements. They're just simply characteristics of systems that will likely make something more feasible idea in terms of economics and operations. Again, being in close proximity isn't surprising. Of our own sewage lines will make constructing them new or retrofitting them more cost effective and reduce any heat loss while getting to your system. You can also use sewer heat recovery with all types of HVAC distribution systems, but oftentimes we've found folks with water-based systems that go after it. And also, since this source of heat comes from a system that we don't control the input into, we obviously can't and don't tell people when to take showers, do laundry, do the dishes, open restaurants. We can't always guarantee there will be flow containing all this heat to be recovered. That said, historically, flows don't ever stop in our interceptor conveyance lines anyway. So flow not being available isn't something we'd actually expect to happen. I think we'll go to the next one too. Yeah, so what really is sewer heat recovery? Again, it's been used for a long time. It's just common proven systems applied in a new way to be more efficient. It just means that the building's heating system won't need to produce as much heat because it's using what's already in our own sewer system. Everyone has at least one heat pump in their home already. It's your refrigerator. The center graphic here shows just a cross section of a fridge. Basically just a simple overview. A fridge has 4 stages. The heat pump in the fridge. First, you start in the fridge with all the heat from the stuff you put into it. Heat naturally moves to cold, so it's absorbed into the cold refrigerant in the evaporator coil. You see in the graphic there, the blue evaporator coil. The refrigerant, it's then compressed and turned into a gas, and then the heat's radiated away from the fridge on those coils that you have to keep all the dust from collecting on. Then the refrigerant goes through an expansion valve where it loses pressure and cools further and becomes a liquid again, and is pumped back through the evaporator to collect more heat from the fridge and do the same thing over again. So this fridge, it's just like sewer heat recovery. Instead of the room temperature stuff we're putting into the fridge, we've got warmer raw sewage with heat that will be transferred to the evaporator. It's really just a simple process. It's just now with the focus on sustainability, we're trying to really realize we have a big resource here that we can reuse. And with that, I'll pass it on back to Erika.
Thank you, Carl. Yeah, that's exactly right. So we are calling for pilot projects right now. The council has authorized us to go forward to do this. So we are seeking 2 projects at this time. And the deadline for initial consideration is December 18th. So that's coming up really quickly. And we are hopeful that we'll get a lot of great projects. We hope to have more than 2. That would be a great problem to have. And we just wanted to note that we are asking interested users, one of the thresholds to be considered is to be at 30% design for the whole project, not just for the connection portion, but for the whole project. That's the way we're going to assess readiness of the project to go forward, because we just don't want to hold a space open in a pilot project for a project that's not actually going to go forward. And we have a website. The address is right here, and there's lots of information there about our process, how you need to apply, and a copy of the user agreement, so you can see if the terms work for you. This is just a kind of a process map of how a user might express interest. Number two, we would talk with the user for, answer questions about feasibility, what kind of pipes are in the neighborhood of their project, and do some help in helping figure that out. We would negotiate the contract. There's not actually much to negotiate. As I said, the council has approved that template, and we're pretty bound by those terms. We would sign that, and then the project would commence, and we would do it. So that's the process in general. Again, I would direct you to our website for further information. This is what it looks like. You will want to click on the potential users drop-down menu, and that's where really the meat is right now. And in particular, there's a FAQ document with further links to that sewer viewer map that I had showed you earlier that you can click on. It's interactive, and you can see where your project is in relation to a line, and other documents and things like that. So I think that's all we have from King County, and I am going to stop sharing my screen and turn it over to Ryan Green from Sharc. Thank you so much.
Awesome. Thank you very much, Erika. Really, Erika and Carl, fantastic lead into, I think, this whole thing, and, really good explanations as far as, how this is fitting together for you all. And, really hats off and applaud to King County for their efforts and what they've been able to produce here, because I think it's a fantastic program that, really I hope catches on in multiple other areas across the US and across the world, as far as a new way of providing energy efficient and low carbon heating and cooling for buildings. So my name is Ryan Green. I'm with Sharc Energy Systems. I am the Western Regional Sales Manager. A little bit about me: I've got a mechanical engineering background from the University of Arizona in Tucson. And then I've got about 10 years experience in the HVAC industry, where I've been working with different types of HVAC equipment, particularly ground source heat pumps and those types of water-cooled, water-based systems. So that's where I was introduced at one point in time to Lynn Mueller, the founder and CEO of Sharc Energy Systems, back in around 2011 time, just shortly after they were founded. 2016 was really an exciting year for Sharc. Released the PIRANHA, got the AHR Innovation Awards. Several awards started building up. I think one real exciting thing about this graph is, as you move to the right and as time has gone on, we're progressively getting more and more attention, and more things are coming towards Sharc. Here in 2020, I'd say our most valuable thing that came to us was the opportunity to compete in the Electric Power Research Institute, where we were able to get, really third-party verification of some of the performance of our wastewater heat recovery equipment. As far as that equipment is, we've got two series. We've got a smaller series that's, more kind of a building scale. And then we've got a larger series that's, more for the district energy system type stuff that you've heard a little bit about. I'll start with the smaller, the PIRANHA series. It is, basically it's a packaged heat pump water heater that's using raw wastewater as its source. So you heard Carl talk a little bit about, heat pumps taking heat from a source. That's what this is doing, is it's taking that heat from the raw wastewater and then transferring it into refrigerant. Got some further graphics that explain a little bit more, but really in a nutshell, the PIRANHA, it's capable of doing domestic hot water, heating hot water, snow melt, radiant. The heating cooling model can also do condenser water economizing as well as chilled water production. Performance-wise, hot water temperatures up to 140, chilled water down to 38. Performance of COPs in the 5.0 range when we're simultaneously heating and cooling, sometimes upwards of 8. Because this is an electrically powered heat pump, we're not combusting any fossil fuels. So this aligns directly with the efforts to reduce greenhouse gas emissions all across, particularly for districts like Seattle 2030, those 2030 districts. We are also using a low GWP refrigerant. We've recently switched over to R513 in efforts to also, address the concerns of refrigerants. And also because it is electric, can be powered by on-site solar, so integral part of electrification for utilities, and different users can quickly fit into their net zero building statistics. Kind of going back to the heat pump water heater, breaking it down even more. So there's two different types of heat pump water heaters out there. There's air source and water source. One is taking heat from the outside air, transferring it to that refrigerant, and then transferring it to your domestic hot water loop. The second type is taking that heat from a water loop, usually condenser water, and transferring it to that refrigerant and then onto your domestic hot water loop. So again, very similar in concept. The standard PIRANHA is taking raw wastewater, taking that energy, putting it into the refrigerant, into the domestic hot water loop. So you can kind of see a similar graphic to what Carl had there above the refrigerator. We're taking that heat from the wastewater into the evaporator, goes into the compressor, is compressed to a high pressure. Then the condenser, where the domestic hot water takes that energy and puts it out to the system, goes back into the expansion valves, cools back down as it cools back down from a gas, and the process starts all over again. So it's nothing fancy. It's really very simple, and that's what I think is super exciting about the PIRANHA, is that it's fundamentally it's just a heat pump, and it's just changed what its source it's taking its energy from. Really, when you're taking a look at the PIRANHA itself, it's got simple connections to it. You've got your wastewater inlet. Internally, there is a tank, and that tank is actually, it's our evaporator coil that allows us to extract the energy from raw wastewater and transfer it into the refrigerant loop. So that tank then fills up with the raw wastewater. As it fills completely, there's an overflow. As we drain the energy from that raw wastewater and transfer it to the domestic hot water loop, it is then drained out to the sanitary sewer. The PIRANHA HC model, which I mentioned does heating and cooling, is very, very similar in process. So the heating process from the wastewater is the same, except what we've done is we've combined the process of taking heat from a condenser or chilled water loop and also then amplified the performance of the PIRANHA. So we're taking heat from raw wastewater as well as providing a chilled water source for building, ambient cooling, things like that, to amplify and get that increased COP performance of the heat pump itself. Looking at that model, there really is no change in most of the piping. Fundamentally, we've just added that additional evaporator coil that's allowing us to provide chilled water out to a system. Building scale wise, when we're looking at how it goes into a building, the wastewater tank there on the bottom right, as the wastewater leaves the building, it's going to go into that tank. A float system is going to maintain the level in that tank. So contrary to most tanks where you're not going to be maintaining a level, we want to maintain that usable liquid level, because that wet well is essentially our thermal battery. So we will, as there's a call for heat in the building, the pump is going to pump wastewater into the PIRANHA. Again, it's going to fill that internal tank. We're going to use the energy in that tank, provide the domestic hot water. As that energy is used, the actuated valve here opens up, drains all the used energy out to sanitary, so we're not putting used energy back into our warm source, and then the process starts all over again. So it's really it's almost like the heat pump cycle on the outside with water. We're just recycling what's leaving that building and was previously wasted, as as discussed, with 90% of that heat's just leaving. So we want to take that, capture as much as that heat leaving the building and then put it back into use for domestic hot water or really any other hot water or cooling source in the building. For the larger series, is the Sharc series, mainly designed for our larger flows, getting a lot of attention in the district and district utility side of things. So electric heat pumps provide the heating, cooling, and hot water when they're combined with the Sharc. This again aligns with any of your electrification initiatives. There's zero fossil fuel consumption and then can be powered by on-site solar PV. Also, when we're rejecting heat to the wastewater source, we're able to reduce or eliminate the run times on cooling towers, which anybody who's been around cooling towers know they consume tremendous amounts of fresh water. So that's going to be, coming up another battle that we're going to be fighting here. Is water, to me, is going to be the next oil. So the more we can start conserving fresh water by reducing cooling tower consumption and other different methods like that, the better off we're going to be. So it's another advantage of taking advantage of sewage heat recovery. And again, for any building owners and developers that are looking to hit those green credits and LEED credits and things like that, this type of equipment is going to provide that optimal performance and energy performance and innovation and design credits that are going to align with those types of initiatives. So on these larger flows, the name of the game is filtration and solids removal. If you're not able to effectively filter solids and or remove solids and filter the wastewater, you're going to face problems. And I think that's really one area where Sharc has truly shined. So that picture there on the right is one of our filters that's been in 6 months of operation, 24/7. Roughly almost 520 million gallons of raw wastewater have flowed through that filter. So what you'll see is that circle on the right is where the raw wastewater enters. The filter then takes it down to a smaller particle size, and our solids are filtered out through the bottom and sent right back to sanitary sewage. With the wastewater heat recovery systems and a heat exchanger, a little bit goes a long way. So our systems start from roughly about 100 GPM, and for the smaller Sharc 660, and go all the way up to about 4,500 GPM for the largest Sharc 1212. And of course, one of the best advantages of them is they can be done in parallel to where we can achieve larger flows while not and you know, get larger capacities for these larger district energy systems. The Sharc system itself, really astute, really stout. What you're getting is the macerator, which you can't see behind it, and that's designed to chew up the larger solids before it does enter the filter screen. You get the filter screen itself that does, like I said in the previous slide, is going to filter out your wastewater and remove the solids. That then goes over through the piping and actuator tree over to a plate and frame heat exchanger. That actuator tree is periodically reversed so that we can flush the heat exchanger and really help reduce any potential of clogging or fouling or anything like that in the heat exchanger itself. The Sharc, again, it's a filter, so it has to be combined with heat pumps. And this is kind of what Carl was alluding to, these hydronic type systems. It's the condenser water-based systems that we can combine with. And you know, with that, we can be providing domestic hot water, space conditioning, where we're taking energy for heating or rejecting energy for cooling. Wastewater cooling and industrial process, where we can be doing process heating, steam boiler preheat, clean and process hot water. Another process that's becoming very popular is geothermal heat pump conditioning or hybridization, where we can significantly reduce the amount of boreholes while also still qualifying for hybridization 10% federal tax credits. Application-wise, we're taking the wastewater from that tank, going through the wastewater heat recovery system to Sharc. And then the pink loop here is kind of the one that I consider the most important. That's our ambient process loop. So connected to that ambient process loop can really be any type of water source heat pump, whether it's water to water, water to air, water source VRF, heat recovery chillers, the condenser water loop of a chiller. Any of that can be tied into that loop and then can exchange energy with the sewage through that loop. Again, another application would be the hybrid geothermal. Where we're seeing a lot of attention, you know, particularly from King County and their application status, as well as the National Western Center, is this district type approach. So here we've got that same ambient process loop is the red loop that goes around. Each building is then tied into that ambient loop and then is allowed to exchange energy to and from that ambient loop. And again, this really adds that flexibility for the design teams. This kind of highlights that the choice of systems. So going in those buildings, really they can, you know, there's a variety of types of systems that can be used, and it really doesn't limit the design team's HVAC system choice. And with that, I will stop sharing my screen and I will get this over to Brad. Thank you all very, very much.
Awesome, Ryan. That was, and all three of you, that was fantastic. Can you all see this?
Yeah.
Cool.
It's loaded.
Great.
There you go.
What's that, Matthew?
It's up now. It took a while to load.
Okay, cool. Hi, I'm Brad Liljequist. I work for McKinstry, which is headquartered in Seattle. I know we have folks from all over the place. So McKinstry is a design, build, operate, maintain company that is headquartered in Seattle, but we operate around the United States. We have about 25 offices. We're the 9th largest MEP contractor in the US. We have a very large design and engineering team, about 100 folks, and I'm in that team. Just a little bit about me. I have been at the zero carbon, zero energy space for a long time. Previous to being at McKinstry, some of you may know me from this. I ran the zero energy and carbon programs for the Living Future Institute for about 5 years. I joined McKinstry about 3 years ago. Amazing company and team. And we have today about 20, for reals, about 20 zero energy, carbon, passive, and LBC projects kind of in our system between design and operation and et cetera. I'm going to actually pull the lens back. Ryan, I'm so grateful that you did a deep dive on how the system works, because that was quite thorough and excellent. And just help people to think about this contextually from a district standpoint. McKinstry, we have about, we built a district energy system, kind of a pioneering system, next gen system, where we were doing data heat recovery and transferring it over to Amazon, just not far from, well, it's in downtown Seattle, about a quarter mile, or it's in the South Lake Union area. And that kind of launched us into the district space. And we have we have 7 district systems. We have 2, one that's built in Spokane, one that's under development. And we have a handful of others in various forms. I will say we are currently, we are just finishing design development, like not just feasibility, but full tilt design on a major one in Seattle right now, in conjunction with the county and city. I'm under NDA on that, so I'm not going to be able to talk about it in detail, but I'm certainly going to be sharing some of the things that we've learned. But all that said, before, I think it's really important to maintain perspective. I'm going to be talking about this a lot from the district standpoint. Sewage heat recovery is an amazing tool, and I think thinking about it holistically from a district standpoint is really important and makes it more valuable as a tool. So, this is some of the sensibility that McKinstry brings to the table when we think about neighborhood energy or district energy. First is, it's a great way to achieve zero carbon targets. Sewage heat recovery is the next step in efficiency beyond, say, an air source-based heat pump system. So it's a great connection with that. It's one of the reasons why I think its time has come now. Shared energy, we've already talked about that, and I appreciated what Ryan was sharing about thinking about hybrid systems. If you think about energy districts and, people, the holy grail is waste heat and waste cooling and taking advantage of all those things. And oftentimes, if you're building the system that's a water-based system that's using just water as a thermal transfer mechanism, sewage heat recovery could be a platform to that, but then you could also do other forms of heat recovery. It could be a data center, it could be all sorts of things. It gives you a lot of flexibility to think creatively about it. We really believe that the next generation is going to be utility connection and utility partnerships. The reality is the end game is not a bunch of zero carbon buildings. It's going to be a zero carbon world. And, the grid is going to be an integral part of that. The ability to do thermal storage in conjunction with these sort of thermal loops is hugely beneficial. The idea that you can shift key operation of key systems to the middle of the night when the grid is the quietest and the thermal load, or to shift your load to the points where it's the most renewable, for example, is really kind of, I think, the holy grail and where we're headed. If you listen to Google, they're starting to talk about zero energy, zero energy, you know, like not just on an annualized cycle, but in real time. And that's, I think, where we need to go. Digital backbones, I think, you know, a lot of the times what we're talking about, Ryan was mentioning this idea of, you know, a condenser water loop, and all that is kind of a loop that at a district scale would be transferring this sort of warm water as the thermal base. That's a lot of work to build that, especially in an existing setting. You might be doing auger boring, you know, steel sleeves, those sorts of things. That's an opportunity to actually do a hardwired data connection and electrical connection that is hack proof. That alone might be worth half the value of that significant sunk cost. And then the idea that at a district scale, you can do engaged users. So anyway, I know that wasn't direct on sewage heat recovery, but I do think, you know, as I know there are folks thinking about this at a district scale. So first of all, let's shift to talk about some of the things that we've learned about sewage heat recovery. One is it's for real. It's like, you know, people hear this and it's like, okay, you know, and it's like, yeah, no, it actually is, it's a real thing. It's not common, but, you know, worldwide, there's probably 60, 70 systems operational. There's not too many that are really large, but, you know, we have done enough on the design side to be really comfortable with, you know, where that's all headed. You know, just some thoughts about how to think about it. And I guess the other thing I'll say related to that is, you know, it's sort of like, well, people have been talking about this for a long time. Why is it just now, you know, starting to get more traction? The reason why I think is we're just at that point in the curve. You know, I mean, 10 years ago, people weren't even heating with air source heat pumps. They were heating with boilers, you know, and now Seattle code is air source heat pumps. You know, Washington State, most stuff is being heated, their base load with air source heat pumps. So the next generation in efficiency are water-based heat pump systems, and sewage heat recovery is kind of at the extreme end of efficiency of that, along with heat recovery systems. So it's just time, especially in jurisdictions where people are pushing the envelope further. You know, just some things to think about. If you're thinking at a district scale, you know, if honestly, it's a lot of work to it's an appropriate amount of work, but to tap the sewer main, all that stuff, you know, there's soft costs, management, all that stuff. If you're going to do it, you want to extract all the BTUs that you can out of it. So the idea of creating a sharing loop or system that has multiple properties, you know, just go for it. The system that we're using, we actually are maxing out what we think is the viable BTUs based on the flow rate of the sewer that's adjacent to us. It's the system we're involved in it's serving 4 buildings, large buildings. Look for other benefits. I already talked about that. Ryan already talked about this, but you know, if you're an engineer and you're thinking about this, just think about this as basically a replacement to a ground source loop. And it is actually also, because it's warmer than ground temperature, it's actually even more efficient than the ground source system. You know, we're into an era where, boy, you know, if you're in a suburban setting where you can put a ground source system under a parking lot or whatever and build it kind of in a parallel timing, you know, sure, that's great. You know, ground source vertical systems in an urban environment under a building, you know, it extends your construction timeline 2-3 months. If you have a wet site, you have dewatering, all sorts of things. Like ground source systems are not a slam dunk, and they are they're going to be of limited capacity in a lot of times to serve the building. So again, the sewer, in a way, it allows you to build that in parallel sequence rather than in linear sequence time-wise. From a thermal standpoint, it works pretty well. I mean, it works well in Seattle. You know, again, it's better than the air. You know, it's really cold here. It's in the 30s and the 40s. The sewer's in the 60s. Where, you know, the holy grail to me of these systems is actually the upper Midwest. So, You know, we heard about the National Western Center, Denver, you know, cold climate, Minneapolis, Chicago. That's where these things just are going to rock, because air source heat pumps are just not nearly as efficacious there, and you're having to rely on boilers as an alternative much more often. I will share that the details of the point of connection with the county system are very important, like how much flow is in there. Ascertaining and verifying how much flow is in there is really important. What's the nature of the pipe? How deep is it? How are you going to get at it? Is it under a street? You know, it's like there's a lot in that. And so you're talking about very much both a civil and sewage type system. You're kind of building like a little pump, you know, a little sewage lift station, you know, so, and then you have the mechanical side. I'm not saying that as like scaring people off, but just there's a lot to that. And we certainly, you know, we've been working on the system that we're doing the development on for 2 years now, and we've learned quite a bit in the process. So one kind of threshold decision that you're going to have is, are you doing a condenser loop, or does it make more sense to send out hot and cold direct from a centralized energy plant? There's pros and cons to both. The one that we're working on, we settled on a condenser loop, just a single warm loop that's the same temperature as what we're extracting from the sewer, and then the buildings do the work from there. But you could have a central plant where you do everything, you do all the heating and cooling, and then you shoot the temperature you need out to the buildings. And then that's I'm happy to talk to anybody if you have follow-up questions, please reach out. I know, Matthew, we wanted lots of time for answering questions, and we have 6 minutes, but yeah, thank you.
Thanks, Brad. Yeah, like you said, we have 6 minutes. We have quite a few questions in here. Brad, would you mind stopping your screen?
Yeah, sorry about that.
So first question here is actually, before we start, I can actually keep this going for a little bit longer, so because we do have some questions. So if others are on the panel are willing to stay, that would be great. So first question here is from Juliana to Erika. Juliana Plant from Liljequist Lewis. How many applications do you currently have, and is there a potential for more than 2 projects or 3 projects, because that's how many are in the pilot, if there is a lot of interest?
Yeah, that's a great question. Thank you. As Brad alluded to, we already are working with one pilot project, and we hope to sign them up. And so to fill those other 2 slots that the council has authorized for us, that's why we have an open call for pilot projects right now with that deadline of December 18th. So we are not sure yet exactly how many proposals we will get in the door on that. We hope it's at least 2, if not more. If we don't get to, I should say also, we're going to just leave it open. And then after that, it will be, you know, first come, first serve until we get to 3 pilot projects on board. If we have more than that, yes, we are going to be, the council's authorizing legislation invited us to, invited our utility to let them know if we had other compelling projects that they wanted to sign up in addition. So we're authorized for 3 with potential to talk about more.
Yeah, I think the only thing I'll add to that is one thing to always remember about these things is they're pilot projects, right? And the goal is to learn from this. Obviously, we're going to do as much as we can at the district level to try and fill those spots and make this pilot successful, so we can go back to council and show the success and show that it needs to be expanded. So next question here is from Caleb Knight from Knoxville, Tennessee. With the implementation of these systems, did your utility find that there was a decrease in the total amount of wastewater that was being treated at the wastewater plant?
I can take that one. In short, there's no difference in the amount of wastewater being treated because, and it's not necessarily immediately apparent, no wastewater is ultimately taken out of the process to do this. It's only temporarily diverted to take the heat out, where it comes right back into our pipes and then all heads back to the plants to be treated. So the amount all stays the same. It's only a portion of temperature that is, in most cases, only temporarily removed from the sewage before more flows in through the pipes further down the line and it goes to the plants.
Perfect, thank you. And then I think the answer to the next question is the pilot projects are being submitted or new developments. That is the case right now, is that there are only new developments?
Actually, we would be considering retrofit. Is that the question? If it's new construction versus, yeah, we're taking all comers in terms of size of project. It could be small, it could be large, it could be a new construction, it could be retrofit. In fact, we hope to get a diversity of project types because that will be the best way for us to get useful information out of the pilot program.
Perfect, thank you. So the next question here is from Josh Johnson. I think there's a similar one from Animesh Roy. I apologize if I've just butchered your name, Animesh. How are wastewater solids like paper or plastic handled so that they don't foul the system?
I will jump in. For particularly the Sharc systems, it's all in previously to the filter is a macerator, which is from a wastewater industrial handling company that's designed to chew up the papers, the plastics, the smaller, or not smaller, but really anything that comes down there to a smaller particle size. And then also a good thing that is considered during the design is when you're doing the wet well design is to put in different weir systems to kind of avoid when the wastewater is coming into the wet well, avoid some of those solids from getting over to the solids handling pumps. Not to get too technical off in the weeds, but that's it all comes down to the design, and then also the macerator will chew up the larger solids that come in before the filtration.
Great.
I can just maybe also jump on. I can share, with our system that we've been designing, this topic has been a topic of a lot of conversation. And in fact, we're still, we're honestly still working with the county to fully understand. We're actually like looking at the contents of a sand trap that's in the line to just make sure we really understand all the weird stuff that drops out of it over the course of a couple of years. And, we're actually like, okay, how many tools are in that pile in that sand trap, and we're going to actually sift it with a bar magnet and a forklift. So anyway, you get into some pretty geeky stuff, but if you can call it geeky, but it's important, but it's also dealable. But it's you definitely are starting to get into design that is more typically associated with like sewage, like small scale municipal sewage treatment systems.
Yep.
Right, thanks. And if you join us to the Vision Awards next year, we'll actually have some of those items available for silent auction.
That's an awesome idea, man. I'm gonna bid hard on that.
I love it.
That's funny.
Michael has a question here for you, Ryan. I think maybe if you just follow up with me, just in the interest of time, on case studies of where one of your systems is being used to reduce cooling tower water use. I think if you could share that with me, I'll put it in the follow-up email.
Absolutely.
But just to kind of tie into one of the other 2030 district programs that we have, we just released a report on rainwater harvesting and reusing rainwater for cooling towers and kind of the benefits and how it makes so much sense to do that. So if you're interested in that, we'll also kind of put that in the chat. We are running out of time. I have a few other questions here that I think might be of interest to folks. Erika, you mentioned kind of energy code in your presentation. I think, Brad, you're probably the best person to ask this to. How easy is it to kind of use one of these systems and kind of go through, I guess, Seattle energy code for this example?
Yeah, I can share that we are in the process of doing that. And so I would say it's quite viable. Questions of, all the questions that you would expect to come up do come up, but it's like, it's an understood and accepted technology. It frankly really helps a lot. I think the county is involved in providing leadership with this, because it kind of gives definitely a sense of reality to the whole thing. And so certainly the Seattle DCD or DCLU, sorry, I'm using the old acronyms, sorry, I can't keep up, but DPD is, they're now aware. So yes.
Great. That's the Seattle Department of Construction and Inspections.
DCI, sorry.
Yeah, see, there's so many acronyms.
Yeah.
And then for Erika and Carl, if I'm a building owner, how do I know if I'm close to a sewer line?
Oh, that's a great question. Thank you. Yeah, we have an interactive map that looks a lot like the one that I showed, that satellite map of Seattle. If you go to our website, the kingcounty.gov/sewer heat recovery, click on the FAQs, potential users, FAQs, there's a link to an interactive map, and you can find your address, your property, and then you'll see if there is a red or green line next to your, how far away it is from you. And you can mouse over that map and it'll give you an estimate of the flow through that area as well as the kilowatt hours. It's just estimate, but to get you started.
Thank you all for being here today. Round of applause virtually for our panelists. Again, this session was recorded. We'll send it out to everyone on the call just in case you missed anything or you want to check up on stuff. And if the panelists are okay, I will share people's contact information as well, just in case people have questions for folks. But have a great rest of your day. If you are in Seattle, enjoy the sunshine, which I think is going to pop out again today. And have a great weekend.